Assalamualaikum. Nama saya Muhammad Kamal bin Azmi. Nombor metrik B0820102006. So saya akan present lab 4, Introduction to 68K Simulator. Ini dia punya objektif dia, equipment, components, synopsis and theory, procedure. 4.1 Introduction to the Easy 68K Assembly Language Tool. First, to begin a session, run the program edit 68K EXE. This is a text editor for 68K assembly language program. When you run, you see the following screen. This code in this window provides a template for your own program. You can erase this code and start again, or you can use it. Note that the provide codes give you the beginning and end of the program. This code puts your program in memory at 1016. The end assembler directive has the label start, which point to the beginning of the program. You must not put data here immediately after the org statement. The first line after start must be a valid 68K instruction. Consider entering a program to display hello world below. The next step is to assemble the code. Click on project, then click on assemble source in the pull down menu. This will invoke the assembler. The code will either assemble successfully with no error or unsuccessfully with one or more error. If you have an error, you have to re-edit your code and then assemble it again. You repeat this step until you have no error. So, tekan assemble source menu ni kat sini. Then when you have successfully assembled the code, and you need to click on execute to invoke the simulator. At this stage, you can execute the code line by line and observe the execution of the program. At this stage, what you will see is as below. And next, to start the program, you will press the run button, which resembles the assemble button. After program runs, you should see the below windows. Lepas kita run tu, kita akan nampak benda ni lah. Macam ni. So kita run, dia akan keluar hello world. Lepas tu then remove line message dc.b hello world at 0, place AC string in memory at message. Add below code to previous program after removing step 12. Okay, so ini dia. Review memory. Okay, ini adalah memori data dia. Ini. Okay. In your report, explain what happened when you execute your code in step 13. CR, LF and DC.B Microprocessor Technology CTSK. DC.B Hello FTK Students 0 is our string variable called message, which is initialized by DC.B and has a null terminator at the end 0. 0 terminator is required so that the printing subroutine knows when to stop printing. Then assemble and run your program. So bila kita run, akan keluar ni lah. Hello FTK student, Microprocessor Technology 68K. Okay. Seterusnya, add below code to previous program after line DC.B Microprocessor Technology 68K. Okay, macam ni. Kita assemble, execute. Dia akan keluar sini lah. Okay. Lepas tu kita run. Dia akan keluar ni. Hello FTK student, Microprocessor Technology 68K. This program show you how to write, assemble and run program. You can also make multiple lines in one DC.B statement. Okay. The label of CR and LF is being used several times in the program. Explain what are these label functions. Okay. CR, carriage return in decimal, return the cursor to the beginning of the line without moving to the next line. And then LR, line feed. Okay. Move the cursor down to the end of the line without going back to the beginning of the line. Okay, next, observe the content of the specific register below after each instruction has been executed and fill in the following table. So, ini adalah table dia. Ada data register, DO, address register, A1 and program counter. Okay, next question. Explain briefly the operation of the following instruction. LEA. The LEA instruction place the address specified by its first operand into the register specified by its second operand. So inilah dia punya syntax dia, LEA, EA. Move.b. Move copies data from the location to another and may be qualified by .b to move 8 bits. Thread. Cause a thread exception. The instruction adds the immediate operand of the instruction to 32 to obtain the vector number. Next, dc.b. Define constant in memory of length 1 byte. The relative address of the first piece of data defined by a DC statement can be referenced by an optional label. If a length extension is not specified, the byte value is used for string and the word value for numeric data. Ini singkat dia. Last sekali, EQU. Equate a value to a label. The EQU directive associate a given value specified by a number or numeric equation with required label. Using this label in subsequent code will result in a direct substitution of the associate value. So ini adalah result untuk task 1, task 2, task 3. Okay. Dan ini adalah discussion. We assemble the language program based on the task given by using the 68SK assembler and simulator allows to write 68SK assembly language program that assembles into 68SK binary code on a PC, then execute this code as if it were running on a real 68SK microprocessor. The simulator enables us to execute a single instruction at a time and observe the state simulate register after each instruction is executed. We are able to comprehend and use the assembly language tool to write the code. Run, assemble, source, run to cursor, step over, and so on are some examples. So the last conclusion, sekali. Finally, the objective were met. We can write 68SK assembly language code to run basic device that use data transfer and arithmetic instructions. We also learn how to use simulation software for the 68SK. Finally, we can implement a simple simulation based application. Okay, itu saja. Terima kasih.